Hi folks, this is Karim Raouf from IT Visualizer channel. We will continue our lab, the Matrix Labs, the video number 50. We have been discussing in the previous video the following. We have still working on discussing the Purple Knight Active Directory Security Assessment tool, which is a free tool that will scan your Active Directory for any security holes or any security issues. We have seen that the tests run by this tool is categorized into 4 or 5 categories. The first category of tests is called Active Directory Delegation tests, and we have been going through this test, and the last time we have stopped at a test called Non-Default Access to DPAPI key. Well, from its name, it appears to be a special key that is used to store encryption keys. We will see in details what is the meaning of DPAPI, and we need to uh, give an example how this key will work. Here, this test is making sure that each DC, the access to this keys on the domain controller is done only by special groups. Okay, so he need to make sure that only special groups have access to this key. So non-default principals here is referring to groups. Non-default principal groups are not permitted to retrieve or to access the data on the DPAPI key. So let's see what is a DPAPI key, and we can see here the description: like code of compromise, an attacker could recover all domain data encrypted data of the domain using the DPAPI. So let's see what is the DPAPI and how we can illustrate it by an example. If we go there and ask Perplexity what is DPAPI, let's see the answer, and then we will ask ChatGPT to illustrate it more or to make it in a more simple format. Let's see first what is DPAPI key.
The POPI Data Protection API backup key is a crucial component in Windows environments, particularly within Active Directory AD. It serves as a means to encrypt and recover sensitive data for users in a domain. Here's a detailed explanation of what the POPI backup key is and its significance. What is the POPI backup key? How it works. Each user in a domain. Purpose. The POPI backup key is used to encrypt the master keys of users in an Active Directory domain. This allows users to recover their encrypted data if they forget their passwords or if their passwords are changed. Essentially, it acts as a safety net for sensitive information. How it works. Each user in a domain has a master key that is used to encrypt their data. A copy of this master key is encrypted with the POPI backup key, which is stored on domain controllers. If a user needs to recover their data, the system can use the backup key to decrypt their master key. Unique key pair. The backup key is a unique RSA key pair generated only once when the domain is created. This key is stored as a secret in Active Directory and is replicated across all domain controllers. Why is the POPI backup key important? Data recovery. It enables the recovery of encrypted data when users forget their passwords or when passwords are reset. This is essential for maintaining access to sensitive information without requiring drastic measures, like recreating user accounts. Security implications. Since the backup key can decrypt any user's master key, it is a highly sensitive piece of information. If compromised, an attacker could potentially access all encrypted data across the domain. Risks associated with POPI backup key. Compromise of security. If an attacker gains access to the POPI backup key, they can decrypt any user's secrets stored in the domain. This could lead to unauthorized access to sensitive data, such as passwords and encryption keys. Lack of key rotation. Currently, there is no supported method to rotate or change the POPI backup key once it has been created. If it is compromised, the only recommended solution is to create a new domain and migrate users, which is a costly and time-consuming process. Conclusion: the Poppy Backup Key is a vital security feature in Windows environments that facilitates data recovery for users. However, due to its sensitive nature and the potential risks associated with its compromise, organizations must take stringent measures to protect this key. Regular audits, monitoring access, and implementing the principle of least privilege are essential practices to safeguard the Poppy Backup Key and the sensitive data it protects. Share. Rewrite. Give an example. Answer. Sure, let's go through an example scenario to illustrate the importance of the Poppy Backup Key and the potential risks if it falls into the wrong hands. Example scenario: recovering encrypted data with Poppy Backup Key. Background: in a large organization, the IT department uses Poppy to encrypt sensitive data stored on user devices. The Poppy Backup Key is securely stored on domain controllers to enable data recovery if needed. Step 1. User forgets password. Employee locked out. An employee, let's call her Alice, forgets her password and is locked out of her account. She contacts the IT help desk for assistance. Step 2. IT help desk resets password. Password reset. The IT help desk, following standard procedures, resets Alice's password. However, this action also invalidates her Poppy master key, making her encrypted data inaccessible. Step 3. Data recovery using Poppy Backup Key. Backup Key to the rescue. The IT help desk uses the Poppy Backup Key stored on the domain controllers to decrypt Alice's master key. This allows them to recover her encrypted data and provide her with a new password, enabling her to access her files again. Step 4. Compromise of Poppy Backup Key. Attacker gains access. An attacker, through a security breach or insider threat, gains access to the Poppy Backup Key stored on the domain controllers. This could happen due to weak access controls, lack of monitoring, or social engineering tactics. Step 5. Decryption of all user data. Decrypting sensitive data. With the Poppy Backup Key in their possession, the attacker can decrypt the master keys of any user in the domain. This allows them to access all the encrypted data stored by users, including sensitive information such as passwords, financial data, and confidential documents. Consequences: data breach. The organization faces a significant data breach, with sensitive information being accessed and potentially leaked or misused by the attacker. Reputation damage. The incident damages the organization's reputation, leading to loss of trust from clients, stakeholders, and regulatory bodies. Costly remediation. The IT department must undertake extensive remediation efforts, including changing all user passwords, revoking and reissuing the Poppy Backup Key, and potentially migrating to a new domain if the compromise is severe. Lessons learned: implement strong access controls. Ensure that access to the Poppy Backup Key is restricted to only authorized personnel and that appropriate logging and monitoring mechanisms are in place. Regularly monitor for suspicious activity. Continuously monitor for any signs of unauthorized access or attempts to access the Poppy Backup Key. Develop a key rotation strategy. Explore options to periodically rotate the Poppy Backup Key, even though it is not officially supported by Microsoft. This can help mitigate the risks associated with a compromised key. Educate users. Raise awareness among users about the importance of protecting their passwords and the risks associated with data encryption. This example highlights the critical role of the Poppy Backup Key in data recovery and the severe consequences that can arise if it falls into the wrong hands. Proper management and protection of this key are essential to maintain the security and integrity of sensitive data in an Active Directory environment.
So this is the explanation of Perplexity concerning the DP API key, which is very, very important as we have seen. And we need to make sure that only authorized personnel have the access, or only authorized groups have the access to this key. Okay, so let's see the answer of ChatGPT 4o concerning this test. Here, what I have done, I have taken the description and ask ChatGPT to explain it. So let's see what was the answer of ChatGPT concerning the explanation of the description of what does this test will do. So let's see here what is the answer.
Sure. Let's break down that statement into simpler terms. Indicator. This is a tool or a method used to detect or check something. API calls. These are like requests made by a program to the operating system or other software to perform certain tasks. Think of it as asking a computer to do something specific, like looking up information. DC. This stands for Domain Controller, which is a server in a network that manages security and permissions for all computers within that network. Non-default principals. In this context, principals refer to users, groups, or services that have been given certain permissions. Non-default means these are not the standard, out-of-the-box users or groups that come pre-configured with the system. Retrieve the domain DPoPI backup key. DPoPI, Data Protection Application Programming Interface, is a Windows feature that helps protect sensitive data, like passwords or encryption keys. The backup key is a special key that can unlock this protected data. Retrieving it means accessing this key. LSA Retrieve Private Data. This is a specific function in Windows that allows a program to get private data, like the DPoPI backup key. Simplified explanation. This statement describes a process where a tool checks if any unusual, non-standard users, groups, or services have been given permission to access a very sensitive key that can unlock encrypted data in a network. The tool does this by using special commands, API calls, to ask each domain controller in the network whether these non-standard users or groups have this access.
Very, very good answer. As we have seen here that it analyzes the description of the test very, very good. We now know that the test will ask the domain controller to retrieve the groups that have access to the DP API backup key, which is very, very important because it stores all the encryption keys for users to decrypt their data. So this is very, very good explanation. And here I asked it to provide a script to check whether the DC or the domain control has non-default principals permitted to retrieve the domain DP API backup key. Here, the same. So the test have already a script to do that, but here I'm asking the ChatGPT for OAI tool to provide a similar script written or implemented by the tool to test the same thing. So we can see here, this is the script. I don't know actually it is working or not, but actually I think I have already tested on my domain controller. Anyway, so this is a very, very important thing to note. You need to make sure that your DP API key is secured. But here one question arises. Who has access to the DP API backup key? Who are the default groups that have access to this DPI backup key? So let's ask it a little bit of a question here. I will copy this one and then I will ask ChatGPT, and then I think we can ask also Perplexity here. So you can go there and ask Perplexity. Now we can go there and ask ChatGPT, who or what are the default, let's say, here's saying the principles, so let's use the same principles. Here is referring to users or groups. This is a wider or a broad definition, so I can include users and group in one word. Let's see here, where is the ChatGPT? Default principles that have access to, let's get here the, or let's get the same one here, permitted to retrieve DPA backup key. So let's copy this one and ask ChatGPT that have or that is permitted or that is permitted to retrieve the backup key. So let's get this question and copy this and then ask ChatGPT for O, and then we can ask Perplexity the same question, but I need to open the Pro version of searching, and let's see what will be the answer. So now we can see the answer here. Here is saying that the only or the default principles permitted or the default groups that are permitted to retrieve or to access the DP API backup key is the domain administrators group. Okay, so this is very obvious and very logical thing. We can see here that domain administrator group primary access members of the domain administrator group can read the DPI backup keys. Okay, and we see here one of the weak points of the DP API backup key. It is not rotated, or the password is not rotated. Here SemiCrypt does not support a method to change or rotate these keys, because the key should be changed, or the encryption key should be changed every now and a while, or every during a certain period of time, maybe 1 year, maybe less, but it needs to be changed so the hacker cannot decrypt, or he can hack the key, or he can decrypt the key. Okay, so during the domain initial setup, if the key are compromised, the recommendation is to create a new domain entirely, which is a complex and costly process. I think the key have two parts. One with the user and one with the domain controller. So the key with the domain controller is not changed. I think this is the main problem here. Anyway, so we can see here, this is the answer. Various tools, he's saying tools for extraction. Various tools are Mimikaz and DS internal PowerShell module can be used to extract these keys from the domain controller. These tools exploit the permissions granted to domain administrators to access the backup keys. In summary, the default principle permitted to retrieve this key is the domain administrators group. So this is a very straight answer. If we go to ChatGPT, he's saying that maybe he added also, I think, domain admins, enterprise admins, yes, correct, system. So this is a very straight answer. We can see here that only these groups are allowed to access the DP API key, and the test is making sure that these groups are the only groups that can retrieve the DPA backup key. Non-default, if he checks and see there is some non-default groups that are accessing the DP API key, then that means that there is a hacking process. Okay, so he's checking if there is non-default principles. We have seen what is a default principle. So this is very simple, as we have seen here. This is the test that is very simple to explain. Now let's see the next test, which is enterprise key admins with full access to domain. Here this is a weak point, or this was a bug in Windows Server 2016, that the enterprise key admins group have full access or full control over the domain. This group specifically have different rights than or its default permissions, or what they can do. They are responsible for the encryption keys of the BitLocker. So this is the main responsibility of this group, is to manage and I think retrieve the BitLocker encryption keys. So it's not allowed to control the whole domain. This was a bug in Windows Server 2016. Okay, during the promotion of the domain controller, okay, or during the promoting the server to be a domain controller. This was corrected in a subsequent release of Windows Server 2016 and may not exist in your environment. So here, this was corrected a long time ago, but he is still checking it on the servers today. Maybe someone has not installed the update, but I think this is not. This is a rare case. But anyway, he's checking if this group have access or full access to the domain. He say that since what will happen, or what are the permissions granted to this group because of the bug in Windows Server 2016, they will be the ability to replicate all changes from Active Directory. So they can replicate changes between domain controllers, which is a very, very serious issue. Okay, this only should be granted to certain groups in the Active Directory. So let's first see what are the enterprise key admins. If you need to know what they can do, we can go and search a little bit about Active Directory security groups, and then we can go and open uh, open this Microsoft Learn, and then we can see what this group does exactly. If we go there and check, let's go there and check something. Here you go. Where is here? These are all the description of the groups. If we go there and check enterprise key admins, okay, here is same member of this group can perform administrative actions on key objects in the forest. What are the key objects, or what does it do exactly? What are these keys? He's saying that they are related. When I deep dive in what does this group do exactly, he's saying that it is related to the BitLocker encryption, or the keys for the BitLocker. Members of this group can perform administrative actions on key object within the forest. He didn't give us uh, what does they do exactly, but we can also ask AI tools to provide us with additional data. If we go there and ask Perplexity, what does group in Active Directory do? Let's see also the answer of Perplexity, but I have read before that it is related to the BitLocker encryption keys. So let's see here what they do exactly. If we go further and see, so the enterprise key admins play a crucial role in managing cryptographic keys across the entire AD forest. So they are related to the encryption keys. We're specifically designed to oversee key management tasks related to key objects, which are essential for various security services within the organization. So is say that they can perform administrative actions on key objects that are used across the entire domain forest. This includes managing keys or services like Active Directory, certificate services, and other applications that rely on cryptographic keys. So he is this group is responsible for managing the keys used by different services, okay, and they depend upon encryption. So for example, BitLocker, this is a service or a role depend upon encryption keys. Certificate services also depend upon encryption keys. So he is responsible for managing these keys for these services. Okay, so this could be so this is their uh, uh, role, okay, or their responsibilities. So due to a bug, they are giving full control over the domain, okay. So this is not the issue. We need to make sure that they only can do what is listed here, only to manage the cryptographic keys, and that's it. Okay, if we go further, uh, he say again here say that enterprise key admins does not have any members assigned. We shall typically designate specific users or services accounts to this group based on their roles and responsibility related to key management. So by default, it doesn't contain any members. Okay, and is also protected by admin SD holder. Remember, we have talked about SD holder before. So this is one thing, a very good thing. So these are, or this is the role of the enterprise key admins group. Uh, let's ask ChatGPT also to explain it further. So as we can see, it's saying that manage key admins. Members of this group have the ability to manage members, includes removing, okay, this is the members, okay, managing access to cryptographic keys. Has permission to manage and access to cryptographic keys stored in the Active Directory. This includes the ability to retrieve, backup, and store these keys that are critical security infrastructure of the organization. BitLocker, I have read something related to BitLocker, and now he is adding certificate services also. So it is related to managing the cryptographic keys used by any service or process. Okay, so we can see this is very simple. I think I have seen something here. When I try to search more, I found an article talking about this specific security hole that was in Windows Server 2016. Okay, I think I have already read an article concerning this issue. Anyway, so what we should do, we need to make sure that we have passed this test. Okay, the enterprise key admins should only manage cryptographic keys, okay, and they should not give in full control over the domain. I have seen a screenshot. When you right click upon the domain, you will see that domain admins will have control over the domain, and enterprise admins will have control over the domain, and it was added enterprise key admins will have full control. So this is the issue. You need to make sure when you right click your domain, you should not see this group included in your domain or permissions on the domain, and or at least it should not give in full access. I think I have seen a screenshot or something. Let me try to search. I think I have in my history, I have already seen something like that. Let me search. I think I have already seen that. Enterprise okay, you know, enterprise key admins. Okay, let's see. Okay, I think we can do something here. Let's ask Copilot to search. I think he can get us more info concerning this. Okay, I think this was, okay, he can search us or give us the article discussing this. The text, you know, is referring to a known issue on Windows Server 2016, especially when running AD prep command. A bug could grant the enterprise key admins. Okay, I think here is the reference. This you could give full control. Let's go there. Here it is. Let's go to this one. This is okay, here you go. This is the reference concerning this. Here we can see, or what's talking about. He's saying this is, they are giving full control, permissions to the enterprise, okay, given to the enterprise key domains, okay, full control. I have seen some screenshots before, but let's also see if we have also this article. I think the same, they are the same. So anyway, we have seen that this is a very important thing to make sure that we don't have, or the enterprise key admin doesn't have access to the domain or full control over the domain. So this is one thing, okay? And then we can continue to the next test, which is foreign security principles in privilege group. We have seen before what is a principal. Principal, it is referring to a user or a group. Okay, he is saying foreign security principle. He is referring to users and groups from other domains are added to a privilege group in my domain. So if you have maybe domains, or you have different domains within a forest, okay, so you are adding some users from a domain to other domain, or maybe there is a user from a forest to another forest, if you have trust. He is saying that this indicator looks for members of privileged groups that are foreign security principle. Foreign is referring to not a local group or a group within your domain. Special care should be taken, including accounts from other domains. This is what we are talking about as members of privileged groups. So this should be taken into consideration. Why is this? Because sometimes maybe the group that you are added to you, or the foreign group, or the group that you are added from another domain and added to a privileged group in your domain. So let's, for example, uh, we are taking a user that name Karim from a domain and putting him in my domain admins group in my domain. Okay, this is the example for maybe, or let's consider that I have deleted Karim from my other domain. I need to make sure that it is already removed from my domain admins group. This should be the situation. You need to take or focus on the members, okay, from other domains in your privilege groups. Okay, why not immediately in active one attack? Privileges are not clearly marked as admin count 1 represent an exposure that they may be used nervously with being the case. Okay, so he's making sure that you have, if you have any foreign security principles, maybe users or groups that are added to privileged groups in your domain, need to focus on them and need to make sure that they already exist in the other domains. For example, as I have said in this example, maybe Karim is removed from the other domain, so you should remove him from your privilege group. This should be done, or you should regularly check for the foreign security principles in your domain. This is one thing also to take into consideration. Okay, foreign security principles in privileged groups. So this is one thing we need to make sure. And to the next tests, which will be a very important concept and important test, which is GMSA not in use. Let's first see how much time we have. We have 32 minutes. Okay, so here is referring to, or he is talking about, a special service account called GMSA. Here is this test is checking if I use this type of service accounts in my domain. Here he is saying that I do not use these kinds or this kind of service accounts. Okay, here is saying the indicator check if there are enabled group managed service accounts objects in the domain. For more info, you can right click here and check this article. So you see that he's talking about the GMSA, and we will see now a description about what is GMSA. So first of all, you now know all of the tests. We need to stop first at the GMSA, and let's see the description. If we go to Perplexity and ask it what is the group managed service account, what does it do exactly, how we can activate it, and why it is so important. Let's read and see what is GMSA.
Group Managed Service Accounts, GMSAs, are a specialized type of service account in Windows environments designed to enhance security and simplify the management of automated tasks and services that require credentials. They were introduced in Windows Server 2012 and are particularly useful for non-interactive applications that run across multiple servers. Key features of GMSAs: automatic password management, password rotation. GMSAs automatically handle password changes without user intervention. The passwords are randomly generated and updated on a regular schedule, significantly reducing the risk of password-related vulnerabilities. Password length. The passwords for GMSAs can be up to 120 characters, making them more secure than traditional passwords. No human knowledge. The passwords are not known to any user, which minimizes the risk of exposure. Cross-server functionality. GMSAs can be used across multiple servers, allowing for a single account to manage services on different machines. This is a significant advantage over standalone managed service accounts, SMSAs, which are limited to a single server. They simplify the management of services in environments such as server farms or clusters, where multiple instances of a service need to authenticate using the same credentials. Service Principal Name, SPN, Management. GMSAs automatically register service principal names, which are essential for Kerberos authentication. This simplifies the setup for services that require secure authentication, ensuring that applications can connect without manual SPN configuration. Security benefits. The primary security advantage of using GMSAs is that they reduce the risk associated with traditional service accounts, which often rely on static passwords that can be easily compromised. By automating password management and eliminating the need for manual updates, GMSAs help organizations adhere to best practices for security and compliance. Requirements and setup. To implement GMSAs, certain prerequisites must be met. Active Directory. GMSAs require an Active Directory environment, specifically Windows Server 2012 or later. PowerShell. The setup and management of GMSAs are typically done through PowerShell cmdlets, which require the Active Directory module. Organizational units. OUs GMSAs should be organized within specific OUs for easier management and visibility. Limitations. While GMSAs offer numerous advantages, they are not universally supported by all applications and services. It is essential to verify compatibility before implementation. Additionally, GMSAs cannot be used for certain services, such as the Windows cluster service itself, although they can be utilized for applications running on top of it. In summary, Group Managed Service Accounts provide a robust solution for managing service accounts in Windows environments, enhancing security and operational efficiency by automating password management and supporting cross-server functionalities.
So this is what is the GMSA, but again, something here appears, or I didn't know what is the service principal name. Okay, he said that the GMSA register the account as a service principal name. Okay, so the GMSA is an account that will register, it's a service account that will register itself as a service principal name. What is a service principal name and why should any service account use it? Okay, so why we are registering service accounts as a service principal name? What is service principal name and why should we any account use it? Let's see what is a service principal name. This is a very, very also important concept to know.
Answer. A service principal name, SPN, is a unique identifier for a service instance in a network, specifically within an Active Directory, AD environment. It plays a crucial role in Kerberos authentication, allowing clients to authenticate services securely without transmitting sensitive data. Structure of an SPN. An SPN consists of several components that help identify a service. Service class. The type of service, e.g., HTTP, MSSQL, CIFS. Hostname. The name of the server hosting the service, which can be a fully qualified domain name, FQDN, or just the host name. Port. Optional if the service runs on a non-standard port. This can be specified. Service name. Optional a custom name for the service instance. An example of an SPN format is text. Service_class/hostname port. For instance, an SPN for a SQL server might look like text MSSQL svc/sqlserver01.example.com 1433. Importance of SPNs for service accounts. Using SPNs with service accounts is essential for several reasons. Mutual authentication. SPNs enable Kerberos to authenticate both the client and the service, ensuring that the client connects to the correct service instance. This helps prevent man-in-the-middle attacks. Single sign-on. SSO SPNs facilitate SSO capabilities, allowing users to access multiple services without needing to re-enter credentials, enhancing user experience and security. Service identification. SBNs uniquely identify service instances across the network. This is particularly important in environments where multiple instances of the same service might be running on different servers. Security compliance. Properly configured SBNs help organizations comply with security policies by ensuring that authentication processes are secure and reliable. Troubleshooting. SBNs can be used to diagnose authentication issues in Kerberos environments. If a service fails to authenticate, checking the SBN configuration can often reveal misconfigurations. In summary, service principal names are critical for enabling secure, efficient, and reliable authentication in environments that utilize Kerberos, making them a fundamental aspect of service account management in Active Directory.
So as we can see here, this is a very, very important concept to secure your service account. Okay, what is a service account? In very, very simple term, if you are talking about the group managed service account or a normal service account, this is an account that is used to run a service in Active Directory, especially on a server. Okay, so a normal service account, it is an account that is used to run a service on a server. Okay, the group managed service accounts, it is an account that manage different services on different servers using one account only. So the difference between the group managed service accounts and the normal service accounts, a service account is an account used to manage a service on one server only. But for the group managed account, it can be used to manage different services on different servers with one account. Okay, so this is what we mean by group managed service account. Here he is saying that I do not use this in my environment. Okay, so basically I don't have anything that can be used or I don't have something that I can use GMSA to run it. If we go to ChatGPT and ask it to explain it, I think most of you see that maybe Perplexity is using more technical terms. Maybe it is hard to understand. So let's see how ChatGPT will simplify it in a more simpler terms. Let's see. Here I'm asking it the same question, what is GMSA?
Group Managed Service Accounts, GMSAs, are a feature in Windows Server that allows for the management of service accounts in a more secure and automated manner. These accounts are designed for use with services, applications, and tasks that require domain credentials, offering a way to manage these accounts centrally without requiring manual password management. Key features of GMSAs. Automatic password management. GMSAs automatically manage the passwords for service accounts, ensuring that they are complex and changed regularly without requiring administrator intervention. Shared use across multiple servers. Unlike standalone managed service accounts, MSAs, GMSAs can be used by multiple servers, making them ideal for load balance services or applications spread across several machines. Kerberos constrained delegation. GMSAs support Kerberos delegation, allowing services running under these accounts to access other services on behalf of the user, with constraints to limit what these accounts can do. No manual management of SBNs. GMSAs simplify the management of service principal names, SBNs, as they are handled automatically by the system. Use cases. Application pools in IIS. GMSAs can be used to secure application pools in Internet Information Services, IIS. SQL Server Services. GMSAs are commonly used for SQL Server service accounts, especially in clustered or multi-server environments. Task Scheduler. Windows Task Scheduler can use GMSAs to run scheduled tasks with domain credentials. Benefits. Security. Since GMSAs handle password changes automatically, the risk of compromised credentials due to weak or static passwords is reduced. Ease of management. Administrators no longer need to manually rotate passwords or manage service account credentials. Scalability. The ability to use GMSAs across multiple servers makes them ideal for enterprise-scale applications and services. Requirements. Windows Server 2012 or later. GMSAs require at least Windows Server 2012. Domain functional level. The Active Directory domain functional level must be at Windows Server 2012 or higher. Active Directory. GMSAs rely on Active Directory for password management and SPN management. Implementation. Create a GMSA. Using PowerShell, administrators can create a GMSA using the new AD service account Cmdlet. Install the GMSA on servers. Use the Install AD service account Cmdlet to install the GMSA on servers that need to use it. Configure services or applications. Services or applications can be configured to run under the GMSA by specifying the GMSA's name as the account under which they operate. For more detailed information, you can refer to Microsoft's official documentation on group managed service accounts here. Would you like more information on a specific aspect of GMSAs?
So here you can see it's a very simple explanation. I think more simpler than Perplexity answer. Again, I was asking it what is service principal name and why we should any service use it. Okay, so this is a concept to secure the service account. Okay, so let's see here what is this one.
A service principal name, SPN, is a unique identifier that is used in Kerberos authentication to associate a service instance with a service account in an Active Directory environment. SPNs are critical for enabling Kerberos to correctly authenticate services, particularly in scenarios where services run on different hosts or under different accounts. What is an SPN? Unique identifier. An SPN is essentially a string that uniquely identifies an instance of a service. It typically includes the service type, the host name, and sometimes a port number or service name. Example of an SPN format: bash, copy code, http:/webserver.example.com, mssqlsvc/sqlserver.example.com, 1433. In these examples, HTTP and MSSQLSVC are the service types. Webserver.example.com and SQLserver.example.com are the host names. 1433 is an optional port number, used here for a SQL Server instance. Why should any service account use SPNs? Kerberos authentication. SPNs are vital for Kerberos authentication. When a client attempts to connect to a service, it uses the SPN to request a Kerberos ticket. The SPN tells the Key Distribution Center, KDC, which service the ticket is for, enabling the KDC to issue the correct ticket. Ensuring the correct service is accessed. The SPN ensures that the authentication process is directed to the correct service instance, especially when multiple services of the same type are running across different hosts or under different accounts. Delegation scenarios. In scenarios involving Kerberos delegation, where a service must access resources on behalf of a user, SPNs are necessary to ensure that the service can correctly represent the user when accessing other resources. Avoiding authentication issues. If SPNs are not correctly registered or configured, Kerberos authentication can fail, leading to fallback on less secure NTLM authentication or outright access denial. Misconfigured SPNs can also lead to authentication being routed to the wrong service instance, causing security or operational issues. How SPNs work. Registration. SPNs are registered in Active Directory under the service account that the service is running as. This can be a user account, a computer account, or a managed service account like an MSA or GMSA. Lookup. When a client needs to authenticate to a service, it looks up the SPN in Active Directory to find the correct service account. Ticket request. The client then requests a Kerberos ticket for the service, using the SPN to specify the target service. The Kerberos Key Distribution Center, KDC, issues a ticket that is encrypted with the service account's key. Authentication. The client sends the ticket to the service. The service, using its associated account, decrypts the ticket to authenticate the client. Example scenario. Suppose you have a SQL Server instance running on a host SQL Server.example.com using a service account SQL SVC. The SBN for this SQL Server service could be bash, copy code, MSSQL SVC /SQLServer.example.com. 1433 This SBN would be registered in Active Directory under the SQL SVC account. When a client application connects to the SQL Server, it requests a Kerberos ticket for this SBN, allowing secure authentication. Managing SBNs. SBNs can be managed using command line tools such as setspan or through PowerShell. Administrators typically add or remove SBNs as needed when configuring services. Importance. Proper management of SBNs is crucial for maintaining secure and efficient Kerberos authentication within a network. It ensures that services can be correctly identified and authenticated, preventing potential security issues or service disruptions. For more detailed guidance, including how to manage SBNs, you can refer to Microsoft's documentation on SBN management. Would you like more information on how to set up and manage SBNs or any specific use cases?
So as we can see, very detailed answer and simple. And why I am exploring the different answers of different AI tools, because most of these answers complete each other. One AI tool can provide an answer and the other one can provide another answer which add more details, okay, or add more or additional information. So we can see here, for example, the answer of Claude 3.5 Sonnet. What is a group managed service account? Here is the answer.
Group Managed Service Accounts, GMSAs, are a feature in Microsoft Windows Server that provide enhanced security and management capabilities for service accounts. Here's a concise overview. Purpose. GMSAs are designed to manage passwords for service accounts automatically, reducing administrative overhead and improving security. Key features. Automatic password management. Simplified service principal name, SBN management. Ability to be shared across multiple servers. Benefits. Increased security by eliminating static, long-term passwords. Reduced administrative tasks related to password rotation. Improved compliance with security policies. Use cases. Running services, scheduled tasks, or applications across multiple servers. Managing accounts for clustered services or load-balanced applications. Requirements. Windows Server 2012 or later. Active Directory domain services with Windows Server 2012 Force functional level or higher. GMSAs address many of the security concerns associated with traditional service accounts while simplifying management tasks for IT administrators. Would you like me to elaborate on any specific aspect of group managed service accounts?
So the second question, what is the service principal name and why should service accounts use it? So let's also see the answer of Claude and then read it loudly.
Service ac- Understanding group managed service accounts. Service principal names, SBNs, are an important concept in Windows authentication and security. Here's a concise explanation. Definition. An SBN is a unique identifier for a service instance in a Windows domain environment. Format. Typically, SBNs follow the structure: service class / hostname, port / service name. Purpose. Allows clients to identify and authenticate a specific service on a particular server. Enables Kerberos authentication for services. Why service accounts should use SBNs. A. Authentication. Enables secure Kerberos authentication between clients and services. Prevents impersonation attacks by ensuring clients connect to the intended service. B. Single sign-on SSO. Facilitates SSO in domain environments. Users don't need to re-enter credentials for each service. C. Service isolation. allows multiple instances of a service to run on the same server with distinct identities. D. Delegation enables controlled delegation of authentication, allowing
Sorry guys, just wait for a moment. Let's continue guys.
services to act on behalf of users. E. Auditing and tracking improves ability to audit and track service usage and access. Management. SPNs are typically registered in Active Directory, can be managed manually or automatically, as with GMSAs. By using SPNs, service accounts can participate in the domain's Kerberos authentication system, enhancing security and enabling more sophisticated authentication scenarios. Would you like me to expand on any specific aspect of SPNs or their relationship to service accounts?
So this is the GMSA explained by 3 tools. Now we need to go and ask the most important question: how to enable GM or how to enable GMSA accounts? How this is done? There is some steps to be done. Okay. We can read also the answer. I have already asked the 3 AI tools the same question, and every one of these give an important tip on how to do that. So let's first see the answer of uh, Perplexity.
To enable Group Managed Service Accounts, GMSAs, in a Windows environment, you need to follow several steps that involve configuring your Active Directory and using PowerShell commands. Here's a concise guide to help you set up GMSAs. Prerequisites: Windows Server version. Ensure you are running Windows Server 2012 or later. Active Directory. Your Active Directory AD schema must be updated to support GMSAs. Domain controllers. At least one domain controller must be running Windows Server 2012 or later with the Microsoft Key Distribution Service, KDS, enabled. PowerShell. You need PowerShell installed to execute the necessary commands. Steps to enable GMSA. 1. Create the KDS root key. This step is required only once per forest to enable password generation for GMSAs. Open PowerShell with administrative privileges and run the following command. PowerShell. AGS root key effective immediately. Note: the effective changes may take up to 10 hours to propagate across all domain controllers. 2. Create a security group. Create a security group in Active Directory that includes the computer accounts of the servers that will use the GMSA. This allows you to manage permissions more easily. 3. Create the GMSA. Use PowerShell to create the GMSA. You will need to specify the name of the GMSA, the DNS name, and the security group that can use it. For example, PowerShell. New ID service account name, GMS name. DNS host name, gmsname.domain.com. Principals allowed to retrieve manage password, your security group. 4. Install the GMSA on target servers. On each server that will use the GMSA, you need to install it with the following command. PowerShell. Install AD service account identity, GMSA name. You can verify the installation by running PowerShell. Test AD service account identity, GMSA name. If the command returns true, the GMSA is installed correctly. 5. Configure services to use GMSA. Finally, configure the services that you want to run under the GMSA. This can typically be done through the service properties in the Services Management Console or via PowerShell. For example, to set a service to use the GMSA, you can use PowerShell. Set service name, your service name. Credential, GMSA name. Conclusion. By following these steps, you will have successfully enabled and configured a group managed service account in your Windows environment. GMSAs simplify the management of service accounts and enhance security by automating password management and allowing services to run securely across multiple servers.
So this is the answer. If we go to ChatGPT, it will provide the same answer but with additional tip. Okay. For example, the propagation of the key that will be used to provide, or to the key that will use to provide or create the GMSA password, he will put -10, which will propagate the key immediately. It will not wait for 10 hours. So let's see here the answer and see how we can enable GMSA.
Enabling and using Group Managed Service Accounts, GMSAs, involves several steps, including setting up the necessary infrastructure, creating the GMSA, and configuring services to use the GMSA. Below is a step-by-step guide on how to enable and use GMSAs. Step 1. Ensure prerequisites are met. Active Directory Domain Functional Level. Ensure your domain functional level is at least Windows Server 2012 or higher. This is required to support GMSAs. Windows Server Version. The server where the GMSA will be used must be running Windows Server 2012 or later. Kerberos Key Distribution Center. KDC. Ensure that your KDC is properly configured and functioning. Active Directory PowerShell module. Ensure that you have the Active Directory PowerShell module installed on a domain controller or a workstation that you'll use to create and manage the GMSA. Step 2. Create the Key Distribution Service, KDS, root key. Before creating a GMSA, you need to create a KDS root key, which is used by the domain controllers to generate passwords for the GMSAs. Open PowerShell as an administrator on a domain controller. Run the following command to create the KDS root key. PowerShell, copy code. Add KDS root key, effective time, get date.add hours, -10. The effective time parameter sets the time when the KDS root key becomes effective. The example above backdates it by 10 hours to ensure it's available immediately. Step 3. Create the GMSA. Now, you can create the GMSA using the new AD service account command. Open PowerShell with the Active Directory module loaded. Run the following command to create a new GMSA. PowerShell, copy code. New AD service account. Name MyGMSA account. DNS hostname domain.com. Principals allowed to retrieve managed password. Server $01, server $02. Name. Specifies the name of the GMSA. DNS hostname. Specifies the DNS name of the domain. Principals allowed to retrieve managed password. Defines which computers, servers, can use this GMSA. You can list multiple servers separated by commas. Step 4. Install the GMSA on target servers. Once the GMSA is created, it needs to be installed on the servers where it will be used. Log into the target server where the GMSA will be used. Open PowerShell as an administrator. Run the following command to install the GMSA. PowerShell, copy code. Install AD service account. Identity MyGMSA account. Identity, the name of the GMSA created earlier. Verify the installation by running. PowerShell, copy code. Test AD service account, MyGMSA account. This command should return true if the GMSA is properly installed and working on the server. Step 5. Configure services to use the GMSA. Once the GMSA is installed, you can configure services to use it. Open the Services Management Console, services.msc, on the target server. Locate the service you want to run under the GMSA. Right-click the service and select Properties. Go to the Logon tab. Select this account and enter the name of the GMSA in the format domain/account name $. The $ at the end is important as it signifies that this is a GMSA. Leave the password fields blank and click OK. Step 6. Verify service operation. Restart the service to ensure it runs correctly under the GMSA. Check the service logs and functionality to confirm that the service is operating as expected. Step 7. Monitor and maintain the GMSA. Automatic password management. The GMSA's password is managed automatically by Active Directory, so you don't need to worry about changing passwords manually. Review security and usage. Periodically review which services and servers are using the GMSA to ensure compliance with security policies. Additional tips. Delegation. If the service using the GMSA needs to delegate credentials to other services, you may need to configure Kerberos delegation for the GMSA in Active Directory. SBNs. If the service requires Kerberos authentication, ensure that any necessary service principal names, SBNs, are registered to the GMSA account. By following these steps, you can successfully enable and use group managed service accounts, GMSAs, in your environment. This setup provides a secure and efficient way to manage service accounts across multiple servers. Would you like more details on any specific part of this process?
So this is the answer, and the final one we will see the answer of Claude 3.5 Sonnet. And I think, okay, the answer is a little bit different, maybe more shorter, but let's read it loudly and we will close this subject, or this will be the last thing in our video. And let's read it loudly.
Enabling Group Managed Service Accounts, GMSAs, involves several steps. Here's a concise guide on how to set up and use GMSAs in a Windows Server environment. Prerequisites. Windows Server 2012 or later. Active Directory domain services with Windows Server 2012 Forest functional level or higher. Domain controllers running Windows Server 2012 or later. Prepare the domain. Run PowerShell as administrator. Execute. Add case root key. Effective immediately. Note, in production, use effective time parameter to delay key generation. Create a GMSA. Use PowerShell command. NAID service account. Name. Install the GMSA on member servers. On each server that will use the GMSA, run. Install a service account. Configure services or applications to use the GMSA. Update service configurations to use the GMSA. Format. Domain /GSNAME$. Manage GMSA permissions. Grant necessary permissions to the GMSA in Active Directory and on local resources. Optional. Set up Kerberos constrained delegation. If needed, configure delegation settings for the GMSA. Test the GMSA. Verify that services start correctly using the GMSA. Test authentication and access to resources. Key PowerShell complets for managing GMSAs. NAID service account. Get AD service account. Set AD service account. Remove AD service account. Test AD service account. Remember to plan carefully before implementing GMSAs in a production environment, especially considering which services and servers will use them. Would you like more details on any specific step in this process?
So as we can see here, this is the answer of Claude. And now we will stop at this point. So we have seen a lot of tests today, and the upcoming video we will discuss the next test, which is non-privileged users with access to GMSA passwords. We will stop at this point. Hope this video is informative to you all, and thank you all for viewing. Thank you so much.